Okay, so get this. Trying to build a website back in the early 2000s was a total headache.
I can imagine.
It was like trying to build a house with only a hammer and nails.
Wow.
You needed tons of expensive hardware.
Okay.
The software was like deciphering ancient hieroglyphics, and it took forever.
Oh, I bet.
But then came along Amazon Web Services or AWS, and boom, they made it easy and affordable for anyone to launch their website.
That's fascinating how that same story is playing out in the world of blockchain today.
Really?
Building a functional blockchain can feel like those early website days.
Interesting.
It's complex, it's resource intensive,
Okay.
and unless you've got a team of experts in deep pockets, you're probably not going to compete with the big players.
So what's the solution?
Well,
are we all doomed to be stuck with the blockchain giants forever?
not necessarily. Enter Polkadot, a platform that's aiming to be the AWS of Web3.
Interesting.
It's designed to simplify blockchain development
Okay.
and make it more accessible for everyone,
Got it.
instead of building everything from scratch.
Right.
Polkadot provides the infrastructure and tools.
So you can just focus on your application.
Exactly.
Okay, hold on. Let's back up a bit.
Sure.
For those of us who are just getting acquainted with Polkadot,
Okay.
what exactly is it? And how does it work?
Polkadot is what's known as a layer 0 blockchain.
Okay.
Which essentially means it's the foundation upon which other blockchains can be built.
Okay.
Think of it like the bedrock that supports an entire ecosystem.
Okay, I'm picturing this blockchain bedrock.
Yeah.
So how do these other blockchains,
right,
or parachains as I've heard them called,
yes,
connect to Polkadot?
That's where it gets really interesting.
Okay.
Polkadot has this ingenious system where individual blockchains, those parachains, can connect to the main Polkadot network called the relay chain. This connection gives them access to Polkadot's shared security, interoperability, and scalability, all without having to reinvent the wheel.
So it's like each parachain is a unique building.
Exactly.
But they're all built on the same solid foundation.
Right.
So they're inherently more stable and connected.
Exactly.
And each parachain can have its own specific purpose and functionality.
Yeah.
You could have one for decentralized finance.
Right.
Another for supply chain management.
Yeah.
Another for gaming. The possibilities are vast.
Exactly.
It sounds like a brilliant way to foster innovation and diversity in the blockchain space.
I think so.
So how did Polkadot come to be?
Well,
who's the mastermind behind this?
Polkadot is the brainchild of Dr. Gavin Wood, a co-founder of Ethereum, and a leading figure in the blockchain world. He envisioned a future where blockchains could seamlessly connect and communicate with each other.
Interesting.
And that vision led to the creation of Polkadot.
So this wasn't just some random project.
No, not at all.
It was built by someone who was literally there at the birth of Ethereum.
Exactly.
That's some serious blockchain pedigree.
Absolutely.
And the development of Polkadot didn't happen overnight.
No, it took a while.
It took years of meticulous research, design, and engineering to bring this vision to life.
It's a complex project.
In fact, the first version of Polkadot was launched back in 2017.
Yeah.
And it's been constantly evolving and improving ever since.
That's right.
Speaking of evolution, there's a lot of buzz about Web3 these days. Where does Polkadot fit into this whole Web3 landscape?
That's a crucial question. To understand Polkadot's role, it helps to look at the evolution of the web. We started with Web 1, which was basically just static web pages.
Like online brochures?
Exactly.
Yeah, I remember those days.
Yeah.
You could look at information, but there wasn't much interaction.
No.
It was kind of like a one-way street.
Yeah.
Then came Web 2, which brought us dynamic websites, social media, and a whole new level of user interaction. Suddenly, everyone could create and share content, connect with each other, and build online communities.
Yeah, that's right.
Web 2 was a huge leap forward.
It was.
But it also came with its downsides.
Of course.
I mean, think about all the issues we're facing today. Data privacy, censorship, and the dominance of a few tech giants.
You're hitting on a key point.
Yeah.
Web 2, for all its advancements, became heavily centralized, with a handful of companies controlling vast amounts of data and wielding enormous power.
So where does Web 3 come in? And how does Polkadot play into this shift?
Web 3 is the next iteration of the internet, and it's built on the principles of decentralization, transparency, and user ownership.
Got it.
It's about returning power to the users and creating a more equitable and democratic online experience. And that's where Polkadot comes in.
So Polkadot is like the infrastructure layer for Web 3. The foundation upon which these new decentralized applications and services can be built.
Precisely.
Polkadot provides the tools, the security, and the interoperability needed to make Web 3 a reality.
That's right.
I'm starting to see how all of this connects. How Polkadot's history and its vision for the future of the internet are intertwined.
Yeah, it's very interesting.
It's a fascinating journey.
It is.
And we're just getting started.
Exactly. It is. We're just getting started. Let's dive into some of those Parachain projects. Would you like to know more about what's being built on Polkadot?
Oh, absolutely. Color me intrigued.
Okay.
What are some of these standout Parachain projects that are really catching your eye?
Well, one that comes to mind is Akala. Think of it as a DeFi hub, offering a suite of financial tools built on a parachain. That means it leverages Polkadot security and interoperability for things like stablecoins, a decentralized exchange, and liquidity protocols.
So it's like a one-stop shop for all things DeFi.
Yeah.
But with the added security and efficiency of being on Polkadot, that sounds pretty compelling.
It is.
For developers and users alike.
Yeah.
And then you have Moonbeam.
Yes, Moonbeam.
Imagine a bridge that connects Ethereum and Polkadot.
Right.
That's what Moonbeam does.
That's right.
It allows developers to easily move their existing Ethereum projects over to Polkadot.
Yeah.
Opening up a whole new realm of possibilities.
It does.
That's a game changer.
It is.
Especially for developers who are already invested in the Ethereum ecosystem.
Right.
It's like suddenly being able to tap into a whole new market and infrastructure without having to start from scratch.
Exactly.
Precisely. It's all about making blockchain development more accessible and flexible.
That's right.
Now here's another one that's pushing the boundaries.
Okay.
Astar.
Astar.
It's a multi-chain smart contract hub that supports not just one, but multiple virtual machines.
It does.
Okay, I'm sensing a theme here.
Okay.
It seems like a lot of these parachains are focused on interoperability.
Yeah.
And bridging different blockchain ecosystems.
You're spot on.
You're spot on.
It's a core principle of Polkadot.
Okay.
And it's one of the reasons why it's gaining so much traction.
Okay.
And then you have projects like Centrifuge, which is focused on real-world asset financing.
Okay.
And Affinity, which is all about creating a next-generation NFT marketplace.
Real-world assets, NFTs. Those are some hot topics right now.
They are.
I'm starting to get a sense of the sheer breadth of innovation that's happening on Polkadot.
It's truly remarkable to see how these parachains are tackling diverse challenges and pushing the boundaries of what's possible with blockchain technology.
Now, I know we talked about the relay chain earlier, but I'm still a bit fuzzy on how these parachains actually connect to it.
Okay.
It can't be as simple as just plugging in a cable, right?
Right. It's a bit more sophisticated than that.
Yeah.
Polkadot uses a system called slot auctions.
Okay.
Essentially, developers who want to launch a parachain need to compete for a limited number of slots on the relay chain.
Ah, so it's like a bidding war.
Yeah.
For prime real estate on the Polkadot network.
You could put it that way.
The bidding is done using Polkadot's native token, DOT.
That's right.
And the winners get to connect their parachain to the relay chain for a certain period.
Yeah.
So it's not a permanent connection.
No.
What happens after their lease expires?
They need to participate in another auction to renew their slot.
Okay.
It's a way to ensure that the most active and valuable parachains are the ones that get to benefit from the relay chain's security and interoperability.
It's like a constantly evolving ecosystem, where only the fittest parachains survive.
Exactly.
That's a pretty fascinating dynamic.
It is.
Exactly. And it helps to keep the network efficient.
Right.
And prevent it from becoming bogged down with inactive or outdated projects.
Yeah, that's right.
Now, before we move on, there's one more key aspect of Polkadot that we should explore.
Right.
It's economic model.
Okay, let's talk money.
Okay, let's talk about money.
How does Polkadot make sure the network stays secure?
Right.
Incentivizes participation and funds ongoing development.
Well, Polkadot uses a multifaceted economic model that cleverly combines staking, governance, and transaction fees.
Okay, let's unpack those.
Okay, let's unpack those.
First up, staking.
First up, staking.
Remind me how that works again.
Remind me how that works again.
Staking is all about users locking up their DOT tokens to help secure the network. In return for their contribution, they earn rewards in the form of additional DOT tokens.
So it's like a win-win.
It is.
You help secure the network and you get rewarded for it.
Yeah.
But what's stopping someone from just hoarding all the DOT and controlling the network?
That's where governance comes in.
Okay.
DOT holders also have voting rights, which means they can participate in making decisions about the future of Polkadot.
Okay.
The more DOT you hold, the more influence you have.
So it's like a decentralized democracy.
Right.
Where everyone has a voice and the power is distributed rather than concentrated in the hands of a few.
Exactly.
And then there are transaction fees.
Right.
Every time a transaction occurs on the Polkadot network, a small fee is paid in DOT tokens.
Okay.
These fees help to reward the validators who are responsible for processing transactions and securing the network.
Okay.
So it's like a user-funded system where everyone who uses the network contributes to its upkeep and security.
Precisely.
It's a remarkably well-designed system.
It is.
That incentivizes participation, ensures fairness, and promotes the long-term sustainability of the network.
That's right.
I have to admit, I'm really impressed with how Polkadot has thought through all of these aspects, from its technical architecture to its economic model.
It's very impressive.
So we've covered a lot of ground here.
Yeah.
From the history of Polkadot.
Right.
To the inner workings of Parachains and its economic model.
We have.
What are your final thoughts on all of this?
Well,
where do you see Polkadot heading in the future?
I believe Polkadot has the potential to be a major force in the evolution of the internet.
Yep.
Its focus on interoperability, scalability, and user empowerment is exactly what we need to move beyond the limitations of Web 2.
It's exciting to think about the possibilities.
It is.
A world where we're not beholden to centralized platforms.
Right.
Where we have more control over our data. And where innovation can flourish without barriers.
Exactly. It's a future worth striving for, and Polkadot is paving the way.
You know, it's amazing to think about how far we've come from those early days of the internet. Remember when it was all about static web pages?
I know.
And dial-up modems.
It's remarkable how quickly technology evolves.
I know, it's crazy.
And now we're on the cusp of this whole new era, Web 3.
Yeah.
Where the internet becomes more decentralized, more user-centric, and frankly, more powerful for individuals.
Exactly. And as we've been discussing, Polkadot is right at the forefront of this revolution.
I think so.
But here's the thing.
Okay.
We've talked about the what and the how of Polkadot. But I'm curious about the why.
Okay.
Why should people care about this?
Right.
What's the big deal?
That's the key question, isn't it? It's not just about the technology itself. It's about the impact it can have on our lives. Polkadot represents a fundamental shift in how we interact with the internet and with each other.
So paint me a picture.
Okay.
What does a Polkadot-powered future actually look like?
Imagine a world where you have true ownership of your data.
Okay.
Instead of big tech companies controlling your information, you decide what you share, how you share it, and who benefits from it.
That's a huge deal.
It is.
Especially when you consider how much of our lives are now online.
Right.
Our data is incredibly valuable.
It is.
And right now, we're essentially giving it away for free.
Yeah, that's a good point.
Precisely.
And think about the implications for things like social media.
Right.
With Polkadot, you could have decentralized social networks where you're not subject to censorship or algorithmic manipulation.
No more shadow bans, no more echo chambers.
Right.
Just genuine connections and open dialogue.
Exactly.
That's a social media platform I could actually get behind.
I agree.
And it doesn't stop there.
No.
Polkadot can revolutionize finance too.
Yeah.
Imagine a world where you don't need a bank to access financial services.
Right.
You could have decentralized lending platforms, stable coins that aren't controlled by a single entity, and a whole new ecosystem of financial tools that are more inclusive and accessible.
It's like taking the power back from Wall Street.
I know.
And putting it back into the hands of the people.
Yeah.
It's a pretty radical idea.
Yeah.
But it's one that's gaining a lot of momentum.
And it's not just about finance and social media.
Right.
Polkadot can transform supply chains, making them more transparent and efficient.
Okay.
It can revolutionize the gaming industry, giving players true ownership of their in-game assets.
That's right.
The possibilities are truly vast.
They are. It's pretty amazing.
It's mind-blowing to think about the potential impact across so many different industries.
Yeah.
But I have to ask,
are
there any downsides? What are the challenges that Polkadot faces?
One challenge is awareness and adoption.
Right.
The concept of a decentralized internet is still relatively new to many people.
Right.
It takes time to educate, to build trust, and to demonstrate the tangible benefits of this technology.
I imagine there are also technical challenges.
Of course.
I mean, building a platform like Polkadot is no small feat.
Absolutely.
Ensuring security, scalability, and interoperability across a network of diverse blockchains is a complex undertaking.
It is, but the team behind Polkadot is incredibly talented and dedicated.
Okay.
And they're constantly pushing the boundaries of what's possible.
It sounds like there's a real sense of community and collaboration.
There is.
Driving this project forward.
That's one of the things that makes Polkadot so special. It's not just a technology, it's a movement.
Wow.
It's about people coming together to build a better future for the internet.
Well, I have to say, this deep dive has been incredibly enlightening. We've learned so much about Polkadot, from its origins to its potential to reshape the digital landscape.
It's a fascinating project.
It really is.
It's been a pleasure exploring this fascinating topic with you.
Before we wrap up,
is
there anything else you'd like to share with our listeners?
I would.
Any final thoughts or advice?
I'd simply encourage everyone to keep an open mind.
Okay.
And to explore the world of Web3. Don't be afraid to dive in to experiment.
Right.
And to learn more about the technologies that are shaping our future.
That's great advice. The future is decentralized, and it's happening now.
I agree.
Thanks for joining us on this deep dive into Polkadot.
It's been a pleasure.
Until next time, keep learning, keep exploring, and keep pushing the boundaries of what's possible in the digital world. welcome to the deep dive. Today we're going to be taking a deep dive into verifiable random functions.
VRFs.
VRFs, you got it. And we're going to be doing that using two sources.
Okay.
A video called What are Verifiable Random Functions? And a paper on Polkadot's Join Accumulate machine.
Sounds good. These two sources, even though they're kind of different in how complex they are, both really highlight how important VRFs are, especially for trust and security in decentralized systems.
Yeah, for sure.
Yeah.
Especially blockchains, right?
Yeah, exactly.
One thing that really stood out to me in the video was when they were talking about the lower communication complexity of VRFs. Now that sounds kind of technical, but it's really important for why VRFs are so efficient.
Right. Lower communication complexity basically means that VRFs don't need as much back and forth between different parts of a system. Like, in a blockchain, this would mean faster consensus, you don't need to use as much bandwidth, and performance overall is just better.
Okay, so it's not just about the randomness, it's also about how that randomness is generated, right?
Exactly.
And how it's shared within a system. That's really interesting. But before we get too far ahead of ourselves, let's take a step back and kind of break down what a VRF actually is.
Okay.
How do you even make randomness verifiable?
Well, imagine you have a private key, like your own little secret code. You can use that private key to generate a random value, and then anyone who has your public key can actually verify that the value was created using your private key and that it hasn't been messed with.
So it's kind of like a seal of approval, right? Like a cryptographic seal of approval.
Yeah.
No one can cheat or manipulate the outcome because it's transparent and verifiable.
Exactly.
This is a game changer for things like, lotteries.
Yeah.
Choosing block producers in a blockchain.
For sure.
Any situation where you need things to be fair.
Yeah.
And that brings us to the Polkadot paper.
Okay.
And its use of ring VRFs, which use something called the Bandersnatch curve.
Yeah.
Bandersnatch curve. That sounds like something straight out of Alice in Wonderland.
It does.
What's so special about this particular curve?
Well, choosing to use the Bandersnatch curve wasn't just random. They chose it because it strikes a good balance between performance and the kind of security you need for anonymous validation. Like, some other curves might be faster, but Bandersnatch offers a higher level of anonymity.
Gotcha.
Which is super important for Polkadot's consensus mechanism.
So it's not just about speed, it's also about finding the right cryptographic tools for the chop, right?
Right.
To get that level of security and anonymity you need.
Exactly.
Makes sense. Now, the paper mentions that these ring VRFs, they add a layer of anonymity on top of the verifiable randomness. Can you kind of unpack that a little bit for us?
Yeah, so with a regular VRF, who generated the random value? But with a ring VRF, you can prove that you have a key within a set of keys, but you don't have to reveal which key is yours.
Oh, okay, so it's like you're part of a secret club.
Right.
But you can prove that you're a member without giving away your secret password.
Yeah, exactly.
I'm starting to see how powerful this could be.
You got it.
Imagine a voting system.
Okay.
Where you can prove that you voted without anyone knowing who you voted for.
Great.
That's the power of these ring VRFs.
That's it.
And Polkadot uses this to select block producers randomly and anonymously.
Yes.
Which makes the whole system way more resistant to manipulation and attacks.
Exactly.
It's like this decentralized system that has a built-in shield against corruption.
Yeah.
Pretty impressive stuff.
So, welcome back to our deep dive into VRFs.
Back into the world of VRFs.
Exactly. And the Polkadot paper's Join Accumulate machine, they call it JAM for short.
JAM, okay.
It's a really interesting example of how you can use these VRFs to make a really strong and scalable blockchain system.
JAM. That sounds kind of like, science fiction-y.
Right.
But from what I understand, it's basically this, idea for a trustless supercomputer.
Yeah.
That's built on top of blockchain technology.
Right, and the paper talks about how it's mostly coherent.
Mostly coherent.
Yeah, and that's kind of what makes it special. It's this trade-off that they made to make sure that it's scalable and efficient, but not giving up too much on the consistency and security of the blockchain.
Mostly coherent. What does that even mean in terms of a blockchain?
Okay, so a fully coherent system, that means all the nodes agree on what the blockchain looks like at all times.
Okay.
But trying to get everyone to agree all the time, it can be really expensive in terms of computation, and it can limit how much the system can grow. So with JAM, since it's only mostly coherent,
right,
it means that things can be a little bit different between nodes for a short time, and that lets it process things faster and handle more transactions. So it's kind of like parallel processing, but for a blockchain.
So it's like allowing a little bit of chaos, but in a controlled way to make it run better.
Exactly.
But how do they make sure things don't get, like, too crazy and cause problems, inconsistencies, or even like security breaches?
Well, that's where this whole collect, refine, join, accumulate model comes in. Imagine you've got this huge task that you need to compute.
Right.
Instead of making every single node in the network do all the work, Jam splits it up into smaller pieces.
Gotcha.
So it's like divide and conquer, but for computations. And then in the collect phase, they gather all the data and the tasks that need to be processed.
Okay.
And then refine is where the real heavy lifting happens.
Right.
And that happens off-chain with just a few chosen validators.
Oh, interesting.
So it's super fast and efficient. And then the results of all those refinements, they get joined together and then accumulated back on chain, and that updates the blockchain in a secure and verifiable way.
And I'm guessing VRFs are a big part of making sure this whole process is fair and random?
Oh, absolutely. VRFs are like the key to this whole system. They're used to randomly pick which validators get to be part of the refine phase.
Okay.
So that makes sure it's fair and that no one can control the results.
So it's like a decentralized lottery for validators, where they get chosen to contribute their computing power.
Exactly.
And then all those little pieces get put back together to update the blockchain.
Right.
That's really cool how they combine efficiency and security in such a unique way.
It is, and to make it even more secure, they've also got this auditing and judging mechanism.
Okay.
Basically, other validators, also chosen randomly, they double check the work that's been done by their peers.
So like a peer review system for blockchain computations.
Exactly. So if any validator tries to cheat or mess with the results, they'll get caught during this audit, and they could even get penalized.
Oh, wow. So they're incentivized to be honest and accurate.
Yeah.
Because their work's always being checked by other validators.
Exactly. And because they use VRFs to choose the auditors, it makes sure that the auditing itself is random and fair.
That's really clever.
Yeah.
It creates this self-regulating system where the validators keep each other in check.
Yeah.
Which makes the whole system more trustworthy and reliable.
Exactly.
I'm starting to see why Jam is considered such a groundbreaking idea. It really pushes the limits of what we can do with blockchain.
It does, and it all comes down to how they use VRFs. These VRFs, even though they seem simple, they're the foundation for trust and security and scalability.
Yeah.
And that's what lets them build this powerful, decentralized computing platform.
Wow, my mind is blown. This deep dive into VRFs and Jam has been incredible.
It has.
We've gone from the basics of how to make randomness verifiable to this really sophisticated, futuristic blockchain system.
It's been a journey.
I know, right? But there's still more to uncover. We got to talk about core time and authorizers and how they fit into this whole Jam system.
Yeah, definitely.
Okay, so we're back for the final part of our deep dive into Polkadot's joint accumulate machine. Yeah! We're going to be talking about core time and authorizers.
Yes.
These terms sound kind of like, I don't know, a futuristic economic system inside a blockchain or something.
It is a pretty fascinating system. So core time is basically the lifeblood of Jam. It represents the computing power that's needed to run tasks. You can kind of think of it like gas in Ethereum. But in Jam, core time is actually purchased ahead of time and given to something called an authorization agent.
Authorization agent. Now that's a new one. What do these authorization agents actually do?
Think of them like middlemen who manage core time. They act on behalf of users or whoever wants to run computations on Jam.
Right.
So this pre-purchasing and assigning thing, it makes the whole process a lot smoother and more efficient.
Gotcha. So it's like having a dedicated account manager for your computing needs within Jam.
Exactly.
That makes sense. But where do the authorizers come in?
The authorizers are the ones who actually give the green light for computations to happen.
Right.
It could be individuals or groups or even smart contracts.
Interesting.
And the cool thing is that authorizers don't just randomly decide what gets computed.
Right.
They actually commit some of their own core time to a specific service or task.
Oh, so it's like staking. They're putting their money where their mouth is.
Exactly. So they're backing their choices with their own core time, which makes sure that only the really valuable tasks get done.
That makes a lot of sense. And I bet VRFs come into play here too, right?
Of course. VRFs are used to randomly pick the authorizers from everyone who's staked their core time. That way, no one person or group can control the process.
It's amazing how VRFs are baked into every part of Jam.
Right.
They really are the key to making sure everything is random and fair.
Exactly.
It's like this perfectly choreographed dance between cryptography and decentralized governance,
Yeah, it is. And it gets even more interesting because they also have this authorizations pool.
Okay.
It's basically like a marketplace for core time.
Oh, cool.
Authorizers can change how much they've staked depending on, how much demand there is or what their priorities are.
So it's not just about picking authorizers randomly, it's also about making the system flexible.
Right.
So it can adapt to whatever the GM network needs.
Exactly.
This is seriously impressive stuff.
It's a really clever design. It shows how powerful decentralized systems can be.
Yeah.
By using VRFs and these really smart mechanisms, they've created this platform that's not only scalable and efficient, but also secure and really hard to manipulate.
I've got to admit, when we first started talking about trustless supercomputers and all this stuff, I was a little bit skeptical.
Yeah.
But now I'm starting to see how brilliant this whole thing really is.
It's like we've gotten a sneak peek into the future of decentralized computing.
I know, right? This deep dive has been an amazing journey.
It has.
We've learned about how VRFs work, how they're used in Polkadot's jam, and we've seen the potential of these decentralized systems.
And this is just the beginning. Who knows what other incredible innovations are going to come out of VRFs and blockchain technology.
Exactly. Well, that brings us to the end of our deep dive into verifiable random functions and the joint accumulate machine. Thank you so much for joining us.
Thanks for listening.